In this video, we're going to look at an equivalence that is derived between horizontal mass spring oscillators and vertical mass spring oscillators. If we take the horizontal one that you just saw in the previous two videos, you see that it's a lot easier because your total energy is based upon just 1/2 mv squared, the kinetic energy at any given point in time, plus 1/2 k x squared, which is our spring potential depending upon the stretch of the spring. But when we look at the vertical case, it's a little more complicated, but because we have this mg that's thrown in, that's changing the gravitational potential energy of the oscillator. But because of the fact that as the spring stretches at equilibrium, we know that x of equilibrium, so this is x of equilibrium, is equal to mg over k. We can actually use the expression for the total mechanical energy of 1/2 mv squared plus 1/2 k x squared, where x is measured as the stretch from the vertical highest point down to wherever it is, since this is where my spring is at minimum stretch or unstretched, and this is measuring downward. This x would be a positive increase in spring potential energy, plus mgy, where y will be now the height above the 0 point. I can use this relationship in a substitution here, and through that I can get gravity to cancel out, so that my expression for the total mechanical energy as a mass oscillates vertically back and forth across equilibrium is the same for the vertical and the horizontal. That was a long derivation, and I don't want to show it to you. I don't need you to know how to derive that, but I need you to know that these two scenarios are equivalent. Now, in the vertical case, this x would be how far the mass has moved to and from equilibrium. So a vertical mass spring oscillator oscillates back and forth across its vertical equilibrium, just as a horizontal mass oscillator oscillates back and forth across its equilibrium. And that's going to pay huge dividends for us down the road when we can treat vertical oscillators as horizontal oscillators. And later on in a couple videos, we're going to derive A max and V max, the maximum acceleration and maximum velocity for a mass spring oscillator. And it doesn't matter if I have a vertical or horizontal. These are going to be the same two values. We're going to be able to calculate those values in the same way.